my pleasure to be here at Washington, D.C. And let us introduce ourselves before giving the presentation. Well, my name is Daisuke Kobayashi. My teammates call me just Dais or Daisuke as a nickname. I have been working at Cloudera as a support for a couple years, since 2012. And I'm working as backline support engineer and helping the customers or internal support folks to help complicated issues. I'm an HBASE contributor too.
Okay, hello. My name is Toshihiro. I'm an HBASE committer since last year. And I'm a senior software engineer break-fix in the support team at Cloudera. I mainly handle HBASE, Phoenix, and HDFS cases. I have written and published a book based on HBASE for beginners in Japanese.
Okay, thanks. Well, okay, first off, so what does supporting HBASE mean by at Cloudera? So at Cloudera, we have a big HBASE. Oh, okay. We have a big HBASE user base, and the number of nodes is quite widespread, from 10 nodes to hundreds to 1,000 nodes. So they report various types of issues over support team to our support team every single day, and our job is just simple: fixing their issues and answering their questions. So if we could summarize the problems reported by customers, these are the typical scenarios that we usually see. And fixing performance degradation, or identifying the reason or process which is crashed. And also fixing inconsistencies, which is well-known issue either in HBASE 1 or in HBASE 2. So in this talk, we will specifically focus on the first one. Then from my side, I'm going to introduce the general approach to performance issues, and I will show you the existing tools that we usually use in the context of HBASE troubleshooting. And then later on, he's gonna be talking about the new tool that he's developing right now, which is more intuitive and efficient for performance troubleshooting. So let's get started. So as you may know, fixing performance issues is tough, basically tough. This is because at Cloudera, the number of nodes is different across customers. And they actually run the different number of nodes with different configurations, and then they have different data sets and different use cases. They all are different. And also various types of factors can lead to the performance issues. You know, something like misconfigurations on HBASE or unbalanced loads on region servers, which is known as hotspot because of bad schema design. And also, the region server should be collocated with data nodes, and if the region data doesn't exist in the local data nodes, it has to read from another data nodes, right? And then apart from that, there might be bad OS configurations or network-related issues or disk slowness. And another thing which makes it difficult is that there are various informations exposed through logs or metrics from region server or masters. So whenever we do analyze troubleshooting, we analyze performance problems, we have to pick up the right log snippets and metrics appropriately. So, so in order to take advantages from those logs or metrics, we have to understand what they actually mean, and then when they are logged, and for example, when the particular metric is incremented. And also, it's important to understand what they are not. So for core HBASE developers, it may be easy question to answer. But you know, the HBASE is widespread and used by many users at various industries. And I have been asked from many guys about, hey, what does this mean? And what's the difference between these metrics? Something like that, over and over. So the aim of this talk is to give you the idea of those basic informations to make them to be able to narrow down to the performance problems and make a progress. So to start performance troubleshooting, I think these are the typical and important approach. First, we need to listen to the customers in order to understand what they are hitting, what they are complaining, and also what they want to resolve, right? This is the very first and important steps to be on the same page with them. And then in order to narrow down the performance issues, in general, we should do a top-down approach. Specifically in HBASE, we should look at the cluster itself from the wide view, and then we look at if the resources are utilized and distributed across the region servers. And if something going wrong on the particular region server, we should look at the particular nodes, right? Then all through the performance troubleshooting steps, I like using the use method, which is originally defined by Brendan Gregg at Netflix and Sun Microsystems guy. The use method is designed like an emergency checklist on a flight manual, right? So it's intended to be simple and straightforward and complete and fast. Use stands for utilization, saturation, and errors. Basically, utilization carries a question: how busy is the resource in the particular system? And the saturations can be measured as a length of wait queue, or something like or time spent waiting on the queue. The errors are explicit indication of something going wrong. Then I think it's obvious that use method is not perfect, but it can be used as a very fast checklist to identify the bottleneck in the particular system. So the next question is, what is the resources in HBASE? You know, region server is the worker role and responsible for processing read and write requests. I'm going to focus on region server specifically. So these are the typical resources in the single region server. All user requests are coming into the RPC system first, and then they are queued and processed by hundreds concurrently. For caching, it goes to Memstore for write, and it goes to Blockcache for read. And then it's persisted to the underlying file system, HDFS, at some conditions. So, you know, as you know, the requests always go through that from the top to down. I mean, from the RP system to the HDFS side. So, which means we should always follow this direction from top to bottom. So the next question is, what types of informations are exposed by each resources? For example, at the RPC system, it exposes the number of requests and how many requests getting queued and processed. For Memstore, it exposes the Memstore size, what's the flashed Memstore size, and also the frequency of flash. So using these observability items, we can check how the resource is utilized or saturated. So from next slide, let's walk through each resource one by one. So first, the RPC system. So from this slide, I'm going to show you the metrics and the web UIs and sometimes logs in the slide. And then all those kinds of informations are aligned to the particular HBASE release, which is 2.1. More specifically, it's aligned to CDH 6.2. So, well, as I mentioned, the RPC system is the place where all client requests requests arrive. So we should be able to check how many number of requests are received by the RPC system. Here in the gray area, I'm showing the raw metric, which is exposed via JMX endpoint from the particular region server. The total request count is also exposed through the master and region server web UI. We can just simply compare the resources across region servers using that. If there is something outstanding value, it's a chance to narrow down to the particular region server. If you have been managing HBASE and are familiar with these kinds of web UIs, you may be aware that each column in the table is getting sortable. This is simple but powerful change, I think. We often have a screen sharing session with customers to look at the issues in a real-time fashion. And every time we look at these web UIs, it was difficult to understand what is the highest and what is the lowest, and without doing something tricky stuff. So this sorting functionality makes our lives easier. Then this number is incremented by various types of request call at the RPC server level, as describing in the below. So next, to understand the saturation, the number of requests being queued at a particular point in time is exposed. That is what I'm showing in the gray area too. And the corresponding values, I'm also showing the corresponding value in the below web UI screenshot. As meta table is usually accessed frequently than others, it's isolated from the queue from the normal regions. So if the queue size is constantly growing, it may be indicating something going wrong in processing the request. So we can check how many requests are processed and queued, but so far by the RPC system too. I'm showing the raw metric value in the gray area here. And then since it's just an incremental value, Cloudera Manager can convert this value into rate, which makes it easy to understand how things are going over time. The processed, in this example, the processed is a blue line and the queued is green line. We can see both exactly matches in this example because it's going well. But in case the queued becomes bigger than processed, it's a sign of RPC servers getting slow with some reasons. So we should check the thread dump of the particular region server in order to dig into further. So if the RPC system takes longer than 10 seconds to respond back to the client for a given request, it informs the table and region name in the process logs. However, in case of scan next call is getting slow, none of the table or region name or raw key was informed. So we were really frustrated while troubleshooting because of that. So fortunately, recent HBASE version get this improved by logging the scan details at the end of the log. That is, I'm showing with green marker in the second example. So with this hint, we should be able to narrow down to the particular region to see what's going on, what's going wrong. All right, let's take a look at the Memstore next. So Memstore utilization is exposed via several levels, from servers and tables and regions. Here I'm showing just servers and region level raw metric, along with the web UI information. So I think it's fairly easy to understand the utilization in Memstore. So when using Cloudera Manager, we typically use this sort of queries to compare the total Memstore utilization across region servers. That's I'm showing in the above graph. Also, we can check if there is any outstanding region which utilizes Memstore than others. So that is what I'm showing in the below graph. So what Flash does is persisting data into the underlying file system, HDFS. So which means the Memstore is fully utilized or most likely saturated, right? So this is an example of log snippets where the particular Flash finishes. In HBASE-2, data can be allocated off heap for both read and writes. So given that, this log informs the pure key value data size and the on-heap occupation separately, which is I'm showing with green marker in this example. It's also showing how long does it take to Flash to complete. These numbers should be informative to see how a particular Flash goes, right? Maybe if it takes longer than others, it may be time to take a look at the HDFS performance. HDFS performance too. So using this granular logging of Flash, we can see the frequency of Flash activity on a region server too. In this below example, I'm grouping the output on an hourly basis. That is what I'm using every time when I look at the region server log. So if the total Memstore size across regions is going beyond the limit of global Memstore size, all updates are blocked by the region server until the utilization is getting decreased less than the threshold. This is the typical log message in HBASE-2.1, which is I'm showing in the above example. So here there are 3 lines where each are correlating. So the first one is indicating blocking updates started because the global Memstore size is going beyond the threshold. The second one is indicating how long it took. And the third one is indicating the blocking completed. In the second example below, the clients get the region 2 busy exception for a particular region. This is because the region has too big Memstore in size, which is not flashed yet. This is also a typical indication of saturation regarding the specific region. So let's take a look at Blockcache next. In the context of Blockcache, utilization is a simple cache usage, which is available via raw metric and a web UI2. If the cache is evicted, it means it's saturated. So I'm showing the raw metric on the left-hand side and a corresponding web UI on the right-hand side here. From the top, it's indicating how much the Blockcache resource is used, what's the remaining memory for cache, and the number of evicted blocks. So using Cloudera Manager, we can check the eviction rate, which is converted from the raw metric value. I'm showing the example in the the below graph. If the utilization is higher enough, but the eviction rate is also higher, it's a sign of Blockcache size is too small to handle the current workload. So it's time to think about increasing the cache size. All right, so I'm going to quickly cover the last resource in the picture, the HDFS resource. The HDFS resource utilization and saturations are basically tracked at the HDFS level. So I can't talk much about that in this session, but But I'm gonna show one related metric, which is exposed by HBASE. So that's flash queue size. When flashing Memstore, it's queued first and persisted to HDFS later. So the queue is maintained at the region server level and exposed as a raw metric, and also the corresponding web UI. It's visible through Cloudera Manager charts as well. Typically, its utilization shouldn't be growing. So if the queue is constantly growing, it's denoting flash is failing or getting slow with some reason. So it's time to look at the HDFS side. So that's pretty much all I have prepared for this presentation. So I have been talking about how to look at the resources in HBASE and then their utilization and saturation, mainly from metric and sometimes from logs. I'm pretty sure that I couldn't cover everything, and we have to look further using different approach if we couldn't find anything using this approach. So, but I wish you could find any idea from my talk. So from Toshi, he's gonna give a presentation about the new tool, which makes our life more easier and which is more intuitive. Thanks.
Thank you, Dice. Okay, so from my side, I'm going to talk about htop, and that's a real-time monitoring tool for HBASE. So overview of htop. htop is a tool I'm developing now, which is raised in the Jira ticket HBASE-21926. This is a unique stop-like tool, and we can do real-time monitoring for the HBASE metrics with it. And the motivation of htop. As Dice mentioned, a fast approach when we are facing performance issues to check the current status of the cluster. At this case, we can see HBASE UIs to check the metrics. And it showed the metrics of the moment. But we can't see them in time series from it. If you want to see the metrics in time series, we have Ganglia, OpenTSDB, Cloudera Manager, and Number Metrics. In Number Metrics, we can see the metrics via Grafana. They are useful when we want to see the metrics in time series. But if you are doing real-time monitoring, they are not very useful because collecting the latest metrics takes a little bit time in those tools. For real-time monitoring, I have started to develop htop. I'll explain the features of htop later in this talk. To clarify the position of htop, I made this matrix of the features of those tools. If you just want to see the metrics of the moment, you can use any tool of them. However, in Ganglia, OpenTSDB, Cloudera Manager, and Number Metrics, collecting the latest metrics takes a little bit time. And if we want to see the metrics in time series, you need to use Ganglia, OpenTSDB, Cloudera Manager, or Number Metrics. And if we want to do real-time monitoring, htop is the most useful of them, as it has a lot of features to do that. Okay, from here, I'll talk about the features of htop with demonstrations. Firstly, about htop screen. We can start htop by running htop command. And the UI is similar to unique stop command. The metrics are refreshed in a certain period, 3 seconds by default. And you can do vertical and horizontal scrolling. OK, I'll show you a demo of htop screen. Actually, this is not a live demo, but a terminal recording. And we can see this demo anytime in this URL. OK, so Okay. So this is the htop screen. And the metrics in this screen are refreshed per 3 seconds by default. And it consists of 2 parts, a summary part and metrics part. In summary part, you can see the HBASE version, cluster ID, and number of the region servers, the region count, average cluster load, and aggregated request count per second. In metrics part, you can see the metrics. In this case, you can see the metrics per region, and it shows namespace name, table name, and encoded region name, and region server name, and request count per second, and so on. Also, you can scroll down to see all metrics like this. And you can do horizontal scrolling, yeah, like this. Okay, so next, as mentioned, the refresh delay is 3 seconds by default. But you can change it by pressing D key and put the new refresh delay. And we can also change the default refresh delay by specifying a command line argument -delay. Okay, I'll show you the demo of it. Okay. Yes. If you press D key in htop screen, you can put a new refresh delay. In this demo, trying to change it to 1 second. And yes, it has been changed. Okay, so next. Currently, htop can show the metrics per namespace, table, region server, and region. And they are called, respectively, namespace mode, table mode, region server mode, and region mode. The default is region mode. We can change this mode by pressing M key in htop screen. And we can also change the default mode by specifying a command line argument, -mode. So I'll show you a demo of it. Okay. Yeah. Now you see the metrics per region, and we can change it to namespace or table or region server by pressing M key. Okay. For example, you can see the metrics per namespace, like this. And you can also see the metrics per table, yeah, like this. Okay, so next slide. Yeah. In addition to that, we can choose which fields are displayed in the screen. By pressing F key, you can choose displayed fields. You can also change the order of fields in the same screen. Okay, let me show you the demo. Okay, by pressing F key, move to this screen where you can choose displayed fields. For now, in region mode, these fields can be displayed. And for example, if you don't need namespace and table fields, and if you need region name field, then you can remove namespace and table field and add region name field. And as you can see, the fields are removed and added. Yeah. Also, we can change the order of fields in the same screen. Go back to the screen by pressing F key and select the field you want to move and right key. And then move the field to anywhere you want to move it and press left key. Okay. So you can see the order of the fields is changed. Okay. It's also possible to sort the matrix by the field values. And we can switch to descending or ascending order by pressing capital R key. I'll show you a demo of it. Press F key to move the previous screen. And you can also choose the sort field on the same screen. If you want to sort the matrix by request count per second, choose the field and press S key. So the current sort field is changed to request count per second. And then you can see the matrix sorted by the field. Yeah, this field is the sort field. Okay. So next is filter feature. That's very important, I think. For example, you want to see the matrix in default namespace only. You can specify a filter like this, namespace == default. Or if you want to see the matrix that have more than 1,000 requests per second, then you can specify a filter like this, request count per second greater than 1,000. In this filter feature, we can use the general operations like those. And when we press O key in the top screen, we can add a filter with ignore case. And when we press capital O key, we can add a filter with case sensitive. Also, when we press Ctrl plus O key, we can see the current filters. And when we press equal key, we can clear the current filters. Okay, let me show you the demo of it. Okay, so if you want to see the matrix in default namespace only, press O key, and you can specify a filter like this, namespace == default. And as you can see, only the matrix in default namespace are shown now. And if you want to see the matrix, the test table only, press O key again, and you can add the filter like this, table == test. So now only the matrix in default namespace and test table are shown. Furthermore, if you want the matrix that have more than 1,000 requests, then you can add a filter like this, request count per second greater than 1,000. So we can see only the matrix more than 1,000 requests. Okay, so, and we can see the specified filters by pressing Ctrl plus O key like this. And we can clear the current filters by pressing equal key, like this. Yeah, the filters are cleared. Okay. So the last feature I'd like to introduce here is the drill down feature. We can drill down from namespace to tables, from table to regions, or from region server to regions. With this feature, we can find the hotspot region easily. We can drill down by selecting a record you want to drill down and pressing I key. Yeah, I will show you a demo of it. Okay, if we want to drill down the default namespace to the tables, you can move to the namespace mode and select the default namespace and then press I key. So you can see the metrics for the tables in the default namespace. Furthermore, if we want to drill down from the test table to the regions, select test table and press I key. Yeah, so you can see the metrics for the regions of the test table. Similarly, you can drill down from a region server to regions. Move to the region server mode. Okay. Yeah, move to the region server mode and select one of the regions and press I key. Okay, so you can see the metrics for the regions on the selected region server. Yeah, that is for the demonstrations of the features of htop. Okay, next, let me talk about the internals of htop. Yeah, currently, htop gets the metrics from cluster metrics class from admin get cluster metrics method. Because that needs to access only HBASE master to that. So if we add more metrics to htop, we first need to add more metrics to cluster metrics class. Actually, the metrics from JMX endpoints will give more metrics to us, but it needs to access all region servers, which might cause scalability issues. So I decided not to use JMX endpoints for htop. And I'll talk about the current status of htop. As mentioned, htop hasn't been committed yet, and it's a work in progress actually. However, the basic features have been implemented as I showed you the demonstrations. The remaining tasks for it are some code refactoring and adding some tests. I also need to make documentation for it. Maybe it will be ready for review next month, and once the review is passed, it will be committed.
What version? What version? 2X?
Yeah, the first version for HBASE-2 yeah. And htop in the future. Currently, I'm developing this tool for the master branch and branch 2. So as a next step, we need to support branch 1. And we should add more metrics so that we can see more information from htop. Especially adding response time metrics is required because they are very important for performance troubleshooting. And we can add the metrics per column family, user, and operation like get, put, scan, etc. And I'm thinking about adding system information like CPU usage and memory usage, which might be useful. In addition to that, we can add the useful features in unique stop command like column mapping or batch mode. Okay, that's all from my side. We hope this presentation was important for you. Thank you very much.